Alright, so this time we're doing problem 12 from chapter 5, and the problem says, a rocket of initial mass of 125 kilograms, including all of its contents, has an engine that produces a constant vertical force of 1,720 newtons. Inside the rocket is a 15.5 Newton electrical power supply resting on the floor. Part A, find the initial acceleration of the rocket. And B, when the rocket initially accelerates, how hard does the floor push on the power supply? So, start off. So we've got some kind of a rocket that in here has a box. And the force of the box, basically, well, it's a weight because it's in newtons. So the weight of the box is 15.5 newtons. The mass of the rocket is 125 kilograms. And the force from the engines is 1,720 newtons. So part A, we want to find the initial acceleration. So for A, we use force. The sum of the forces is equal to the mass times the acceleration. So we know that the force is going to be the force of the engines minus the mass times gravity. Which is going to be equal to the mass times the acceleration. And that's what we're looking for. So we can isolate for that. So force is equal to mass times acceleration plus mass times gravity, which we can then rewrite as mass times acceleration plus gravity. We can then divide the mass to the other side. So force divided by mass is equal to acceleration plus gravity. And then we'll just subtract gravity to the other side. So the acceleration is going to be equal to the force divided by the mass minus gravity. So then we'll plug all of your variables in. You got 172 divided by 125 minus 9.8. When you do the math, just double check this real quick. Two divided by 125. Minus 9.8. That gives you an acceleration of 3.96 meters per second squared. So that's your answer to part A. Part B wants to know the force on the box. So for part B, we're looking for the normal force. We're looking for the sum of the forces on the box. And so for that, we're going to use the equation that it's the normal force, but that's going to be equal to the mass times the acceleration plus gravity, because that's going to be the force that the floor exerts on the box. And we're going to use this acceleration. So n is gonna be equal to 1. No, we have to find the mass of the box first, so we gotta take 115.5 divided by 9.8 to get our mass of the box. And that comes out to, there we go, which is equal to 1.58 kilograms. So that's going to be the mass that we put in there. So the normal force is going to be equal to 1.58 times 3.96 plus 9.8. When you do the math, not the mass, you get an answer of 21.7 newtons for the force that's acting on the box.